So, good morning, students. I hope my voice is audible to you. Okay, yes. Okay, let us start the session with one MCQ part. Okay, just a quiz. A language is regular if and only if what? A language is regular if and only if. Just post your answer in the chat box. So, anyone? Yes, the first one. A language is regular if and only if accepted by DFA. Okay, so either DFA or regular expression. Okay, so here only one option is here accepted by DFA. Right. Next one, regular expression are coming to the types of languages or grammars available in theory of computation. Which type regular expression are? So in the last session, I have already instructed you to follow the bottom-up approach. Which type? Anyone? No one. Bottom-up approach. I instructed in the last class. Just follow the bottom-up approach. Type 3, actually. Okay, so type 3, so the finite automata as well as regular expression. Both are coming to the type 3. Okay, so type 2, context-free. Type 1, context-sensitive. Type 0, recursively enumerable. Okay, so just follow the bottom-up approach. Actually, type 3. Okay. Next, regular expressions are closed under what? Yes, D. Yes, regular expressions are closed under the following operations: union, intersection, and clean star. Okay, not clean closure. Regular expressions that do not contain the star operator can represent only finite language, whether it is true or false. Regular expressions that do not contain the star operator. Star operator means what? Closure, right? If the regular expression do not contain any closure means it is finite. Whether the statement is true or false. Only one. What about others? Yes, true. Okay. If your regular expression do not contain any star operator means then the languages should be finite. Okay. Could be finite. And the last one. Okay. Regular expression for all strings starting with AB and ends with BBA. Okay. So write the regular expression for the language starting with AB and ends with BBA. Starting with AB and ends with BBA. Which one is the right regular expression for this problem statement? Anyone? Starting with AB and ends with BBA. So in between, any combination of. So don't follow others. Yes, C is the right one. Okay. C is the right one. Starting with AB, ends with BBA. So in between, any combination of A plus B whole closure, which means A closure, so or B closure, or the combination of AB. Okay. So A combinations, B combination, or combination of AB. This is the actual meaning. A plus B whole star. Okay. So AB, A plus B whole star, BBA, which is the right one. Okay. For the regular expression. So sorry, here I already uh, the answer is explicitly shown in the answer. Okay. So number of states required to accept a string ends with zero. Okay. Number of states required to accept string ends with 10 means definitely three. Okay. So number of states three. So using three states only, you can draw DFA for this problem statement. Okay. This is the DFA for number of states requires to accept string ends with 10. Okay. So I will take one example 001010. The string ends with 10, right? So 00. So same state 0 0 remains in the same state A. Then 10 10 going to the C again 10. Okay. So again 10 means going back to B then 0. Okay. So accepted. Okay. So this is the finite automata, the deterministic finite automata for accept strings ends with 10. Okay. So almost I think the quiz part is over. So the quiz part is over. Next. Yes. So in this topic, the second topic of unit 2, finite automata and regular expression. Okay, so finite automata and regular expression both are the notations of regular language. So you can convert a finite automata to regular expression, and also possible you can convert a regular expression to finite automata. Both things are happened. Okay, because both are the notations of regular language. Both can be able to represent regular language. Okay, so the first part, DFA, deterministic finite automata. Okay, DFA to regular expression conversion. Okay, so this part this belongs to important part B question. Okay, it's a very important part B question. DFA to regular expression conversion. So for this, what's the input? They have given the input as a DFA. Okay, so input is DFA. You have to calculate the regular expression for the given DFA. Okay, so this is the this is the actual formula. Actually, the method which is called RIJ method. Okay, so this is method which is RIJ method. Why I am explicitly instructing here this method is RIJ method means one more method is there. Okay, from that method also can be part of DFA to regular expression conversion. So there are two methods possible for finite automata to regular expression conversion. The first method, RIJ method, sometimes in your university questions, they have explicitly mentioned using RIJ method. Okay, they have explicitly mentioned, right? Okay, so this is the RIJ formula. Okay, so actually this is the formula. So any query, someone is trying to unmute the audio. Someone is trying to unmute the audio. So any query? Okay. First here I j k. Okay, so three variables are here I, j, and k. Okay, so see, I will start with k. Okay, for let us see the problem. This is the given problem. Convert the following DFA to regular expressions. This is the given problem statement. Okay, so what are all the number of states in the problem? And just post your answer. Number of states in this problem. Number of state. It's a not difficult question to you. Yes. Yeah. Number of states in this problem, which is 2. Yes. 2. Since the number of states which is equal to 2, the possible k value which is k equal to 0, 1, 2. Okay, so if your DFA has number of states equal to 2 means what's the k value? 0, 1, 2. Okay, if your DFA has the states number of states which is equal to 3 means what about the k value? 0, 1, 2, 3. Okay, so this is the k value. So k equal to, for this problem, k equal to 0, 1, 2. Okay, so I represent the starting state. state and J represent the final state. Okay, so actually these three variables are in your uh, formula. First, for this problem, I already repeated the same thing. So number of states in this problem, which is equal to 2. So k value equal to 0, 1, 2. So there are three cases are possible in your problem. Okay, the cases are: the first case k equal to 0, the second case k equal to 1, and the third case k equal to 2. So three cases are possible. Okay, the first, let me come to the first case, k equal to 0. Okay, for all problem, you're the calculating k equal to 0. Actually some rules are there to calculate first case k equal to 0. Okay, k equal to 0 means what? If you are putting k equal to 0 means rij power 0. Okay, so rij power 0. So this is rij power 0. Okay, so for k for this case, number of if the number of states equal to 2 means you have to calculate R11. Okay, that which means R11. 111 means it represents the same state transition. 11. Okay, the possible for number of states equal to 2 means how many possible transitions are there in the number of states equal to 2 automata. 1 transition is there, right? So 1 same, which represent the same state. 1 2 means 1 2 is possible transition, and 2 1 and 2 2. Okay, so how many possible transitions are there in the automata which has number of states equal to 2 means 4 R11. So you have to calculate R11 of 0, R12 power 0, R21 power 0, R22 power 0. So if so in your exam, so coming to the exam point of view, so they have given the input as this. Okay, this finite automata. So what are the things you just bring into your mind means, so since this is the number of state equal to 2, so what's the value of k? K equal to 0, 1, 2. So how many cases are there? K equal to 0, k equal to 1, k equal to 2. So how many transitions are possible if number of states equal to 2 means 1 1 1 1 1 1 1, then 1 2, then 2 1, then 2 2. Okay, so first I will calculate R11 of 0. Okay, so R11 of 0. See here, coming to the diagram, R11, it has the transition, self loop, right? Self loop, R11, which is means here is self loop is there. Okay, since this diagram has the self loop in the transition 1 1, so you have to add epsilon. Okay, epsilon. What is the input here? Input which is 1, epsilon plus 1. Okay, so again repeated. So I want to calculate R11 of 0. So coming to the diagram. So in this diagram, self loop is there. 1 1 is self loop. Yes, transition is there. Self loop is there. So you have to, since this is the starting state and this is the starting state, and you have to add epsilon plus 1. Okay, so epsilon plus 1. This case is over. Next, coming to R12 of 0. Is there any transition possible in R12 of 0? Let me check. R12, yes, one transition is there. R12 for the input 0. Just I have add 0 only. Okay, just I have add 0 only in this case. Then I will check R21 of 0. Just coming to the diagram, you have to check any other transitions from 2 1. Actually, no any transition from 2 1, right? There is no any transition from 2 1. That is why I have added here 5. Okay, no any transition, that is 5. Next, coming to the final state, R22 of 0. Okay, since it is the final state, so again starting with epsilon, then how many, it is a self loop. So what are all the possible values? 0, comma 1. So 0, comma 1, which is represented at 0 plus 1. Okay, 0 plus 1. This is the way of calculating the case k equal to 0. Okay, so how many so for k, how many possible values here? R1 for k equal to 0, you have to calculate R11 of 0, R12 of 0, R21 of 0, R22 of 0. Okay, so that case is over. Next, I'll move on to k equal to 1. For k equal to 1 case, you have to apply the
Ma'am,
formula. Solpa.
I have a doubt, ma'am.
Yeah.
Why are we assuming k is equal to 0, 1, and 2, ma'am?
K value, right?
Yeah. Okay. It is a number of states. Okay, ma'am. Okay, ma'am.
Number of states, yes, yes.
Okay, ma'am.
For this problem, number of states equal to 2. Okay, so the k value starting with 0, 1, 2. If any problem having the states equal to 3 means the k value is 0, 1, 2, 3. Okay, so number of states 2 means k 2 plus 1. Number of states 3 means k 3 plus 1. Okay, so
Okay,
understood?
ma'am.
Okay. Next, coming to k equal to 1. Okay, for k equal to 1 case, you have to apply the formula. Okay, what's the formula here? This is the formula. So k equal to 1 means what is the power here? Power, all power which becomes 0, right? So all power which becomes 0 here. Okay, so rij of 0 plus ri 1 of 0, since k equal to 1 here, then r11 because r kk of this is C, this is R K K of K minus 1. So R K K of K, what's the value of K? 1, 1 minus 1, 0. Okay, next I will apply the value for I and J. Next, here R 1J of that, which means Kj of 0. Okay, so I got here just in this formula, I have applied the only value for K. Okay, next, how many values are possible? How many transitions are possible? Again, I have to calculate R11 of 1, R12 of power 1, R21 of power 1, R22 of power 1. So I have to calculate so all for these. Okay, so let me start with R11 of 1. Okay, so R11 of 1. So coming to the formula. So I have applied the values for I and j. So R11 of 0 plus I equal to 1. So R11 of 0. So in this case is fully for k. So R11 of 0 power closer. Okay. Then R11 of 0. Okay. So I have applied the value for I and j in the formula. Next, I have to apply the value based on the previous calculations, previous cases. Okay, what is the value for R11 of 0? So, what is the value for R11 of 0? Epsilon plus 1 here. What is the value of R11 of 0? Epsilon plus 1. I just added epsilon plus 1. Next, R11 of 0 again plus epsilon plus 1. Okay. Next, R11 of 0 again epsilon plus 1, epsilon plus 1 whole closer. So again R11 of 0 again epsilon plus 1. Okay. So the term actually so in this stage only you have to apply some identities. Okay, so you have to reduce your answer. Identities of regular expression. I have already told in the previous day class. Okay, identities of regular expression. What do you mean by epsilon plus r? Anyone can please unmute your mic and tell me the answer. Epsilon plus r, which is equal to what? Epsilon plus r. Anyone please unmute?
Is equal to R.
Yes, r. Okay, it's epsilon plus r, which is equal to r. So epsilon plus 1, which is equal to 1. Okay, then epsilon plus, so here so epsilon plus 1 is which repeated one. Okay, repeated one means you have to write it only one time. That's enough. Okay, because the language for all the things are the same language. Epsilon plus 1, the language is 1. It's for all the three. The languages which is same for all the three. One. Okay, the repeat so one which is repeated here. That is why if any repeated case means just write it out one time. Okay, so epsilon plus 1. Next, epsilon plus 1 whole closer. Okay, so epsilon plus 1, epsilon plus whole closer. So I have written as epsilon plus 1 as 1. Okay, so what's the value of epsilon plus 1? 1. Next, what's the value of epsilon plus 1 closer? 1 closer. Okay, what is the value of 1? 1 closer? 1 closer. Because 1 which is actually added into 1 closer. So, what is the value of 1 closer? Okay, so anyone just unmute your mic. A section, B section. Pratiti. Pratiti. Rajesh. Why Pratiti? Okay, okay. Rajesh. Rajesh is here. Rajesh. What is the value of one closer? One closer. Just unmute your mic and tell me the answer. It's starting with one closer. What are all the languages presented in one closer? Can you please unmute your mic? Okay, leave it. It is starting with epsilon. All combination of one, right? So all combination of one. So the one is added here. That is why just neglect this one. Okay, so one closer means that just 10 of one closer. In this point only, you have to apply some identities. Okay, to reduce the answer. Okay.
Ma'am.
Vignesh, சொல்லுப்பா.
மேம் Rij ன்னு கொடுத்துருக்கீங்கல்ல மேம், அப்ப J ஓட வேல்யூ J is equal to ஃபைனல் ஸ்டேட் தானே மேம்? அப்ப ஃபைனல் ஸ்டேட் நம்ம 2 தானே
இல்லம்மா அப்படி எடுக்க முடியாது அந்த இதுல. அதனாலதான் இந்த பாயிண்ட் நான் ஆக்சுவலா இந்த பாயிண்ட் வந்து ஆட் பண்ணிருக்க கூடாது. இந்த கன்ஃபியூஷன்ஸ் வரும் ஆக்சுவலா. ஐஜே நீங்க இதுல ரெப்ரசென்ட் பண்ணணும்னா ஃபர்ஸ்ட் கே ஈக்குவல் டு நம்பர் ஆஃப் ஸ்டேட்ஸ் 2 அப்படிதானே? நம்பர் ஆஃப் ஸ்டேட்ஸ் விச் இஸ் 2. ஸோ மைண்ட்ல நம்பர் ஆஃப் ஸ்டேட் ப்ராப்ளம் பார்த்தாலே நம்பர் ஆஃப் ஸ்டேட் 2னா ஜஸ்ட் 1 1 1 2 2 1 2 2. ஓகே, இஃப் நம்பர் ஆஃப் ஸ்டேட் ஈக்குவல் டு 3னா 1 1 1 2 1 3. ஸோ இந்த டிரான்சிஷன்லாம் வரும் அப்படிதானே? அப்போ ஒரு 3 இருந்ததுன்னா சோ 1 1 சேம் பாசிபிள் இருக்கும், 1 2 இருக்கும், 1 3 இருக்கும். ஓகே, அதே மாதிரி 2 1 2 2 2 3 2 1 2 2 2 3. அப்ப 3 மீன்ஸ் 3 1 then 3 2 3 3. சோ ஆக்சுவலா இதுதான் பாசிபிள். ஆனா அவங்க டெக்ஸ்ட் புக்ல ஜஸ்ட் ஸ்டார்டிங் அண்ட் ஃபைனல் ஸ்டேட் கொடுத்திருப்பாங்க. நீ ப்ரோக்ராம்ல வந்து அதை அப்படியே அப்ளை பண்ண முடியாது. I equal to here 1 இது அப்படி அந்த மீனிங் கிடையாது. ஓகே,
எஸ் மேம், எஸ் மேம்.
ஓகே. So next R11 power 1, that case over. R11 power 1 case over. Next R12 power 1. Okay, so I have applied the formula in for I. Here I equal to value I equal to 1, J equal to 2. Okay, so I have so I equal to 1, then J equal to 2. So R1 of 0, R11 of 0. This is actually IK. This is RKK thing. Okay, so you have to apply I and J value here and the same formula. So memorizing the formula is enough for this problem, and you have to know some knowledge on identities of regular expression. Okay, next R12 of 0. What is the value of R12 of 0? Previous case R12 of 0 0 only. R12 of 0 0. R11 of 0 the same thing. Yes, epsilon plus 1. R11 of 0 the same thing. Epsilon plus 1 closer. R12 of 0 0. Okay. So coming to the point, epsilon plus 1 closer. So I can write epsilon plus 1 closer, 1 closer. That's enough. Then 0 plus 1 closer 0. Okay, so 0 plus 1 closer 0. You can leave it as this. This is actually enough for this problem, and you can also reduce it. Okay, so how 0 case means one. Here the 0 is common. Okay, so repeated the 0 things. So I have just neglect this 0. 1 closer 0. Okay, so these two also actually acceptable one. Okay, if you உங்களுக்கு ஏதாவது ரெடியூஸ் பண்றதுக்கு உங்களுக்கு some points identities ஞாபகம் இல்லைன்னா நீங்க ஜஸ்ட் என்ன பண்ணிக்கலாம், என்னால இதுக்கு மேல ரெடியூஸ் பண்ண முடியலன்னா keep it as it is. ஓகே, ஸோ அது ஒரு ப்ராப்ளம் கிடையாது. அதில் ஃபைனல்ல பார்த்துக்கலாம். ஸோ ஓகே, next R12 of power 1 case over. Next R21 of power 1. Okay, so R21 of power 1 for here I equal to 2 and J equal to 1. Okay, so I equal to 2, J equal to 1. So I have applied I value and J value. So in the formula, okay, so what's the value of R21 of 0? So R21 of 0 based on the previous case, which is 5. Okay, I just added 5. So 5 plus 5, epsilon plus 1 closer, epsilon plus 1. So everything everything if you are multiplying with 5 means which is 5 only, empty now. Okay, So based on the identity, so the output here is 5 only. Okay, so this is the output 5 1. Next, R2 2 of power 1. Okay, the last case number 2, k equal to 1. Okay, k equal to 1. R2 2 of 1. So again here I equal to 2, j equal to 2. So I applied I value 2, j value 2 in the formula. So I2 2 of 0, 2 1 of 0, 1 1 of 0, 1 2 of 0. So like that. Okay. So R2 2 of 0. What's the value of 2 2 of 0? Epsilon plus 0 plus 1 plus R2 1 of 0 5. So everything multiplying with 5 means 5 only the answer. So 5 plus epsilon plus 1, and then, which means 5 plus R means R. Okay, so the difference. So 5 plus epsilon plus 0 plus 1 means epsilon plus 0 plus 1. So the last answer 0 plus 1. Okay, so epsilon, since y means epsilon plus R equal to R only. Okay, so 0 plus 1 is the answer. So the case is almost for k equal to 1, R 1 1 of 1. Okay, then R 1 2 of 1, then R 2 1 of 1, or R 2 2 of 1. Okay, so the 4 things are over for the case k equal to 1. Coming to the last case. Okay, so since your number of inputs in your given automata, okay, which is equal to only 2. Okay, so it is equal to only 2. So for this case, so I have see, this is the last case, right? This is the last case. Actually, we have to calculate actually what are the things. R1 1 of power 2. Okay, R1 1 of power 2, then R1 2 of power 2, then R2 1 of power 2, and R2 2 of power 2. Okay, these 4 cases are possible, right? But the last stage, I have to here I'm calculating only R1 2 of 2. Okay, so I'm calculating here only R1 2 of 2. So why? So can anyone answer me actually? What is the value of R1 1 of 2? Take a note and calculate this value. R1 1 of 2. Anyone, please do it. And not anyone, so you have to all do it. Okay. Take a pen. So write the formula, Rij formula. Okay. So Rij formula. So you have to calculate R11. Okay. So R11 power 2. So R11, not like that. Rij. Okay. So for this means 2 minus 1. Okay. So based on the previous cases, you have to simply apply the answer. So anyone, please tell me the answer. Just R1 1 of power 2. The last case. Last case, k equal to 2. So I will calculate only for R11 power 2. So I will calculate only for R112 power 2. So from the student side only, you have to calculate R11 power 2. If you are done your answer, just unmute and tell me the answer. More than 10 minutes are there to complete this session.
So, ma'am, one closure.
One closer. So what other answer?
One closure plus one closure 0 into 0 plus 1. அப்புறம் வந்து 5 வருது.
One closer plus
one closure plus one closure into 0. One closure into 0. அப்புறம் 0 plus 1 into 0 plus 1. அப்புறம் 5 into 5.
Oh, 0 plus 1 into 0 plus 1, then 5.
ஒரு 0 plus 1 தான் மேம். ஒரு 0 plus 1 அப்புறம் 5.
So if you are multiplying with 5 means, so these things are eliminated, right?
அது eliminate ஆயிரும். So one closer.
So one closer. Okay, super. டிஓசியில் எவ்வளோ மேக்ஸிமம் நீங்கள் எவ்வளோ ப்ராப்ளம்ஸை ஒர்க் அவுட் பண்ணுறீங்களோ ஸோ அந்த அளவுக்கு தான் உங்களுக்கு வரும் எக்ஸாம் டைமில் அந்த ஃப்ளோ கரெக்டாக வரும். ஓகே, ஸோ ரிமைனிங் இந்த ஆன்சர் வந்திருக்கா? ராகேஷ், வாட் அபவுட் யுவர் ஆன்சர்? ரிஷி, ஷியாம்லா, ஜஸ்ட் அதை ஃபார்முலால அப்படியே ட்ரை பண்ணுங்க. நான் லாஸ்ட் சொல்றேன், எதுக்கு இதுல ஒரே ஒரு கேஸ் மட்டும் தான் கால்குலேட் பண்ணியிருக்கேன். Rakesh, did you receive the answer one closer? The important problem, part B problem, very important one. The next derivation, I will come with the problem which number of states which is equal to 3. Okay, so if number of states which is equal to 3 means actually 1 1 1 2 1 3, then 2 1 2 2 2 3 3 1 3 2 3 3. So 9 cases are possible. Okay, if k equal to 0 means again 9 cases, k equal to 1 means 9 cases, k equal to 2 means 9 cases, and the last k equal to 3, 9 cases are possible, but in the last state you have to calculate only one is enough. Okay, okay, I will come. So in this case, I will calculate only R12 of 2. Okay, R12 of power 2. Why means, coming to the diagram, here, what is the transition between starting state and final state? What is the transition between the starting state and final state? 1, 2. Okay, if 1, 1 means the same starting state, 1, 2 means this is the transition between starting state and final state, right? 1, 2. So 1, 2, this is the transition of starting state and final state. Okay, for example, if 3 states are there, your last state is final state and first one is starting state, means here the transition of starting state and final state means 1, 3. If you are numbered here 1, 2, 3 means 1. So same way here number of states only 2. So 1, 2. So in the last stage, so R1 2 of 2, for calculating R1 2 of 2 is enough. Okay, so actually you have to calculate R1 2 of 2. For calculating this only you have to done all the previous things. Okay, so calculating R1 2 of 2 power of 2, which is enough in the last case. Okay, if number of states k equal to if number of states equal to 3 means what's the last case? K equal to 3. If number of states equal to 4 means 4 actually 4 this is actually almost 5 to 6 pages are occupied. So actually testல வந்து உங்களுக்கு maximum இந்த மாதிரி தான் இருக்கும். Only 2 தான், 3 கேட்கலாம், but maximum அவங்க 2 தான் வச்சிருப்பாங்க. Okay, so 1 R12 of 2. So again I applied the formula R12 power 1, R12 power 1, R22, R22. Okay, so what is the value of R12 power 1? R12 power 1, here value 1 star 0. Okay, so 1 star 0. So I have written as 1 star 0. So same thing. So 1 closer 0. Again R22 of 1, 0 plus 1 whole closer. Then R22 of 1, 0 plus 1. Here this case is also repeated. So and this case repeated, and this case which is actually coming to within the closure only. Okay, so what is the language of 0 plus 1? 0 comma 1. So this language is also included 0 plus 1 closer. Okay, so I just omitted here. Then so finally 1 closer 0 plus 1 closer 0, 0 plus 1 closer. So these two terms are repeated. So I have written as 1 closer 0, 1 closer. Okay, so this is the answer. This is the answer for this problem. Okay, this is the regular expression for the automata, the given automata, this. Okay. So in the last case, so no need to calculate all the four. There is one case is enough in the last part. Okay. So again, the formula. This is the formula for converting your DFA to regular expression. Okay. This is, and keep it in your mind. This is only applicable for DFA to regular expressions, not NFA, epsilon, NFA. Some other automatas are there, right? So this case is this RJ method, RIJ method. This RIJ formula, which is only applicable for DFA to regular expression conversion. Okay. So this is your statement. So this is a number of states which is equal to 2. So number of states equal to 2. So I have to calculate k equal to 0, 1, 2. So the three cases for k equal to 0. So coming to k equal to 0. So four things are possible for number of states which is equal to 2. 1, 1, 1, 2, 2, 1, 2, 2. If R 1, 1 of power 0 means which is the actually var 1 1 means which is the starting state. Since which is the starting state, I have added epsilon here, and it is also have one input transition 1. So epsilon plus 1. R12 of power 0 means R12. So here that input symbol for this transition 0. Just added 0 here. R21 of 0 means I have checked there is no transition. Okay, here there is no transition for R21 of R21 there is no transition. So I have just added 5 here. So coming to the R last one, 2 2. 2 2 means it remains in the final state. So since it is the final state, I starting with epsilon plus here 2 inputs are possible 0, 1. So epsilon plus 0 plus 1. This is the this is the method for calculating the first case k equal to 0. Okay, so for k equal to 0, you should follow this method only. Okay, for k equal to 1 means you have to apply RIJ method based on the previous answers. Okay, so then rk equal to 2. So for rk equal to 1, same thing again, R11 of 1, R12 of 1, R21 of 1, R22 of 1. Okay, so four cases are, we have to calculate the four case values. Then in k equal to 2, this is since this is the last case, you have to calculate only one case is enough. That is R12 of 2. Okay, so R12 of 2, which is enough for this problem. Actually, this is the problem I have taken from your textbook. Okay, so I have already posted the textbook material in your Google Classroom. Just open your textbook and cross check the answers. Okay, so actually in your textbook one table is there. So in the table, so all values are there. R11 of 2, R12 or something. Okay, so this is the typical textbook problem. Okay, so any query? So you have to remember always you have to just go through your identities of regular expression. Okay, so in the previous day sessions, so what are the things we have seen in the previous classes? Operators, three operators. Okay, first one union, second one intersection, third one clean closure. Okay, so three operators of regular expression. So important 2 marks. Then some identities. Okay. Then definition for regular language, then definition for regular expression. Okay, then some problems. Okay, if for the given problem statement, you have to write the regular expression for the given problem statement. So or else the given input is regular expression. You have to write the language for the given regular expression. So these are the possible 2 marks. Okay, so in the previous day sessions, I have covered some 2 marks regular expression. If your given input is regular expression means you have to write the language. If your given input is problem statement, means you have to write the regular expression. Okay, then operators, union, intersection, closure, clean closure. Okay, union, concatenation, clean closure. Okay, so in this case, this is a typical part B. Okay, so for this problem, So your input is a DFA. It may be a transition table. If your input is transition table, means you have to draw the transition diagram from the table. Okay, so that is the easiest way. First, if you're given input is transition table, means for this problem you have to draw the transition diagram, DFA diagram, and then proceed the same things. K for k values, k equal to 0, k what about k equal to 1, what about k equal to 3. Okay.
Gayatri,
ma'am.
have you completed your class?
Okay ma'am, நான் இது முடிச்சிருந்தேன், இந்த ரெக்கார்டிங் ஸ்டாப் பண்ணிடுறேன்.
One more instruction for the students, ma.
Okay ma'am.
Yeah, students, you want to submit your assignment